tonight?
Yeah.
Okay.
Sounds good.
So if everyone has the quiz open, we can start on question 3. And it is, which hypothesis involves equality? I put the null hypothesis.
Yeah, that's right.
And then number 4 is, remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true? This one is the null hypothesis. Question 5, which of the following represents the alternative hypothesis for a two-tailed test? And I put HA, the mean is not equal to 10. That look right to you guys?
Yes. And then for left-tailed, I think that the mean is less than 10.
Okay, the mean is less than 10. Okay, which of the following hypothesis is a right-tailed test? This be
Greater than. Well, that was straightforward.
Yeah. Okay. Okay. Number 8. Which relationship would result in failing to reject the null hypothesis? This one. I'm looking.
P-value.
Do we have an example of the, is it in the, whenever we reject a true null hypothesis, we say that a type 1 error was committed. Assuming the null hypothesis is true, the level of significance A is the probability of getting a value of the test statistic that is extreme enough that the null hypothesis will be rejected. So, would it be the p-value is greater than?
Not sure. We decided the p-value is small enough to reject the null hypothesis. I would say that it's less than if it is rejecting. So
Okay.
Greater than makes sense for failing to reject it. If the p-value is less than the mean, we reject the null hypothesis. No, that's not good.
Let's see. Let me read this really quickly.
Okay, sorry. So I'd say 8 is greater than and 9 is less than the mean. Or the standard deviation, I mean.
The z-score? Is that the standard deviation, or
I think
that looks like the z-score? That is the z-score. Okay, let's see. Which relationship would result in failing to reject the null hypothesis? Which relationship would result in rejecting the null hypothesis?
I'm fairly certain that 8 will be the p-value is greater than the standard deviation, and 9 would be less than the standard deviation.
Mitch, that's the z-score, not the standard deviation. And A is not the standard deviation. That's the level of significance.
Right. Isn't it the same symbol though?
No, the standard deviation's that like O with the swirl on top, kinda.
I guess I'm really bad at symbols because they.
It's a sigma.
Okay.
Okay,
Well,
I'm trying to understand this right here for when we, on page 10 of our reading, we choose A to be some small number so the probability of committing a type 1 error is low. The most common value for A is 0.05, which is equal to 1 over 20. When the null hypothesis is true, there is a 1 in 20 chance that it will be rejected at the 0.05 level of significance. Okay, let's see. Fail to reject the null hypothesis. This would be. Okay. I'm not sure. All right, here. If the p-value is less than A, we reject the null hypothesis. Okay, so number 8 is p-value is less than A. Conversely, if the p-value is greater than A, we fail to reject the null hypothesis. Okay, so we were right the first time. So question 8 is p-value is going to be greater than A. And if the p-value is less than A, we will reject it. So 9 is p-value is less than A.
So I'm looking at the standard deviation and the level of significance symbols, and they're slightly different, and I didn't even notice. One has like one tail on the right, and one has 2.
Yeah.
I didn't even notice that.
Sigma, and then the other one, alpha. Isn't that alpha?
I have no idea.
The Greek symbol. Okay.
Yes, they're Greek.
An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next 2 questions. Which of the following would be appropriate alternative hypothesis? The average claim amount is equal to 1,500. The average claim amount is not equal to 1,500.
That one.
Yep, that one. Which of the following would be appropriate null hypothesis? The average claim amount is equal to 1,500.
I would say that's what it is.
That's what it is. The insurance company randomly selects n equals 40 claims and calculates the sample mean of 1650. Use the information for the next 3 questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? It is a good assumption since the sample size is large. It is not a good sample size. Not a good assumption since the sample size is small. It is a good assumption since the population is normal. It is not a good assumption if the population is not normal.
Hmm. And is this still relevant to the last set of information?
Yeah, I'm looking on page 12 and reading it really quick.
If it
As long
is
as
relevant to the last thing, then I'd say 1650 is not normal to the 1500.
I would say it's a good assumption because the sample size is large. Because we don't know, they don't state if it's, I'm going to say because the sample size is large, because we don't know if it's normally distributed or not. Well, I guess it says right here, the company assumes the distribution of sample mean is normal.
But it's asking if that's a good assumption or not. I'm thinking that it's not a good assumption since the population is not normal. Since the sample mean is $150 higher than the mean they got before.
Okay, but it wouldn't be because the sample size is large enough, because I thought it was 30 and over was large.
I never know. I'm not sure. Like, how do you know when the sample size is large enough?
I thought it was greater than 30.
Oh, really?
Yeah,
That makes
'cause
sense.
that
That
was,
might be what it is then.
I'll put the first one and I can submit this, and if it's wrong, then.
I think it's right because the next question is
Yeah, what's the theorem of the law that justifies your answer in the previous question? Which I think that this is the law of large numbers.
yeah,
Okay.
they correlate.
Or no, it's the distribution of sample means is normal when X is normally distributed or when, thanks to the central limit theorem, our sample size is large.
Right.
So it would be the
Right,
central
the large numbers theorem is like the spread will be.
Yeah.
That's
If
right.
it is the sample size gets larger, the sample mean will get closer to the population mean. So 13 is central limit theorem.
That's right.
Which of the following is a test statistic as defined in this lesson?
I think Z is the test statistic.
Is it? Isn't that the z-score?
Yes.
That's what you're trying.
And it's the same as the test.
So, okay, we need to determine how far the X is from the mean. Since we know standard deviation, you can use the Z-score. This is called the test statistic.
Okay.
The next sentence is where Z is the test statistic, X is the sample mean. Yeah, I'm pretty sure it's Z.
Okay. The historical mean of the sales receipts at a grocery store is 150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with these hypotheses. The null is the mean equals 150. The alternative is the mean is less than 150. She will use the level of significance as 0.05. She takes a simple random sample of 36 sales receipts from her store and computes that the mean is 144. What is the z-score associated with this test? Round to 3 decimal points.
Okay.
And find the formula. Okay, so this one is going to be
30 divided by 6.
so our mean was 150. $144.
I got 0.9, negative 0.9 for the z-score.
So what's the standard deviation in this one? You just do
The standard
0.05.
deviation is $40.
Oh yeah, that's right. It was right up here. 40 divided by the square root of 36. Okay, I need my Excel. I'm kind of slow. 1 second.
Take your time.
Okay. Okay, so I got negative 0.9, so you're right.
How do we do the p-value?
What is the p-value associated with the z-score from the previous question? Wouldn't this be the p-value is the area under the normal, the applet, the probability.
And it's only less than, but not the greater than extreme.
Yeah, it's on the less than side.
So would it just be 0.1841? I'm sorry, 0.184.
0.184. Yes.
Okay.
Okay, what inference would you make about the null hypothesis for this problem? So let me look here.
Well, the p-value is
Greater than 0.5, so
yes.
we fail to reject the null hypothesis.
Yes, I think that is right.
What is your conclusion for this?
Oh,
We have sufficient evidence that the true population mean is less than 150.
p-value is small, that implies the z-score is very large. It is very unusual to get a value of x that is far from the value of the mean given in the null hypothesis. This implies it is not plausible that the mean is equal to 98.6. So we reject the null hypothesis and conclude there is sufficient evidence that the true mean body temperature of healthy adults is not 98.6. That's if you can't reject the null hypothesis, does that mean there's not enough evidence? I'm not sure.
Well, we failed to reject it, so we accepted it. But we don't say accept, we say we failed to reject.
Right.
So
right.
would we say we have sufficient evidence that the population mean is 150?
That
Is our...
makes sense.
Okay, we'll try that one. Question 19. How many more do we have? There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
A type 1 error is committed when we reject a true null hypothesis.
Okay. The researchers decided that instead of using a level significance of 0.05, he will use a level of significance of 0.01, which of the following will be true. The probability of a type 1 error will increase. The probability of a type 2 error will increase. The probability that the null hypothesis is true will decrease. His experiment will be more scientifically valid.
When choosing the level of significance to be a small number, the probability of committing a type 1 error is low. So by making it lower, the probability of a type 2 error will increase.
Yeah, I think that's...
I see that supporting evidence for type 1 errors. I don't see the part about type 2 errors. 1 second. Okay, if the value of the level of significance is very small, the probability of committing a type 2 error will be large. Okay.
So that one's correct. If the level of significance is 0.05, compute the probability of a type 1 error.
Okay.
How do we do this one, Mitch? Where is it at in our book?
I'm not sure. I think it's under 4.5, but I don't see any formulas for how to calculate the chance of the error. Compute the probability of committing a type 1 error.
It must be...
The level of significance is the probability of committing a type 1 error.
That's it?
I think so.
Okay, we'll try it. 0.05.
That's the last question.
Do you want me? I'll submit mine.
Okay. Hopefully we're close.
Okay, number 10 was wrong. And number 18.
It's not too bad.
Yeah. So let me write these ones down.
Alternative hypothesis.
Three is HA.
Which of the following would be the appropriate? They're concerned that it's higher than this, so it could be that the average claim amount is greater than 1,500 as the alternative hypothesis. But it would be like one-sided. But that makes sense if not equal is incorrect. And then 18, I think that the conclusion is
So 10, you put what, Mitch?
for 10, I'm putting the average claim amount is greater than 1,500.
Okay.
And then 18, this is the one we weren't sure about. I'm trying to remember what the other one we thought it could be was. Have to look at the previous questions. Fail to reject the null hypothesis.
I'm just writing down the other ones really quick. King Central. 14. B.
I think 18 is that we have insufficient evidence that the true population mean is less than 150. So it doesn't prove that the null hypothesis is true. It proves that, well, it means that we can't prove that it's not true.
Yeah, but it's false.
Well, I don't think it
Or
proves that
reject.
it's false. It proves that it's possible.
It's possible that we don't reject it.
So I'm gonna put we have insufficient evidence that the true population mean is less than 150, and I'll submit it and see what happens.
Okay.
Okay, everything's right, 100%. So number 10 is the average claim amount is greater than 1,500. And number 18 is we have insufficient evidence that the true population mean is less than 150.
20 type 2. And 21 and 0. Perfect. Okay.
Not too bad.
Not too
Do
bad.
you guys know if we're gonna be able to see what we got, like what we got, the questions on the exam?
Wrong.
Yeah.
Our professor said we had to email him.
Oh, okay. I got one question wrong, and I don't know which one it was.
Oh, you did? Way to go, Mitch. You did awesome.
Thanks.
That is way. So you got like a 96?
Well, actually, I'm looking at it now. I didn't even get an entire question. I got a 32.66 out of 33. So that means I got
Well-
like a part of one wrong. That makes me even more infuriated.
Well, I think because some of them were worth 0.33 and then some of them were worth like
Okay.
0.5. So you probably missed one that was worth 0.33, which is great. I think those were like one of the first ones that we did.
That means I got one of the first ones wrong.
Well, that's
Oh.
okay.
It's all right.
You did awesome. So what was your score?
99%.
Yeah, yeah, that's amazing. That's wonderful.
I failed you though. You said I had to get 100.
Oh, I bet you would have. You're really good at this, so I was guessing that you would. All right, if you guys want to go, you can. I'm just submitting my quiz.
Do you need me to go over like any of the answers? Like
No, I wrote them all
you can
down,
fill out?
so
Okay.
we're good. And I'll just stop the broadcast, and then you guys can get some rest. I want to go to bed early tonight, so.
I feel you.
Way to go, Midge. I'm so glad. Way to go. And congrats to the rest of you guys for doing such a good job on your test. We all passed, so hopefully the next one will be a little easier.
All right, see you guys.
See ya.
Hopefully,